So we're going to go over the cos law again. This is important, so just don't skip this. We use the cosine law if we have three sides, or if we have side beside the angle beside another side. And when we find three sides, we're trying to find this angle, and when we have side, angle, side, we're trying to find this side. But I also want you to be aware that the sine, once you find one side and one angle, it's much easier to switch over to the sine law. So we really only use cos law in this situation because it's got a lot of errors. Now, you can skip to the questions, but this is fairly important. I'd like to show it. Algebra is an incredibly important tool that you should practice and enhance and keep going with. So this formula on the left is perfect when we have side, angle, side. But it's not perfect when we have side, side, side. Because when we have side, 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 they give you this. That's one side, that's the other side, that's the other side, and you're able to fill this and this. But all of a sudden you have to do algebra to get to that. Instead of doing that, let me show you the secrets to algebra. When we're trying to get to one thing here, which is angle C, and we have C and A and B, it is possible to always algebraically do the equation instead of doing the algebra on the spot. In normal, when you're executing an equation that has all the numbers in it, you follow BEDMAS. But when you're trying to solve something, when you're doing algebra and trying to solve for a missing item, one missing item in the equation, you must unravel it. And we unravel it in reverse BEDMAS. Reverse BEDMAS is SAM, SAMDEB. Now I put the cos C in brackets to show you that it's the last thing we do. The first thing we should look for is subtraction and addition to unravel. And you might say, Peter, how can I tell when there's subtraction and addition? We only put these plus signs and these negative signs when there's a subtraction and addition. If they're multiplying, like here, they're all beside each other. But this thing is being added to this thing, and then this thing here in red is being subtracted from those two things. So that means to get this, we got to start by getting this all alone, and we got to go in order of SAMDEB. So I got to look at where is there any subtraction and addition. There's a subtraction there. There's an addition here. So that means, and there invisibly there's a plus in front of this a squared, which means a squared is being added to b squared, and then this is being subtracted. But we're trying to focus on what's happening to c and ignoring what's multiplying it because we're on subtraction addition. And it's clear what's happening to this group and with c in it is that b squared is being added to it and a squared is being added to it. And you can tell because there's an invisible plus here, there's a visible plus here, and this minus here belongs to this stuff. You might be tempted to say, this is being subtracted from it. And you're right, you could move this all to the other side and it might be easier. I'm going to show you both methods. So instead I'm going to say a squared and b squared are being added to this mess. So I'm going to subtract it from both sides. When I subtract it from the left side, it clearly disappears. Sorry, from the right side, it clearly disappears. So I'm going to subtract on both sides. I'm going to start with subtracting it from the left side. So I subtract a squared and b squared from the left side, and I'm going to get rid of this. I'm going to subtract it, therefore, from the right side as well. So I'm going to put this way over here with an equal sign, like that. And because I've subtracted a squared and b squared from the left side, I will also subtract it from the right side. If you look at this, it goes a squared plus b squared minus a squared minus b squared. So it's clear these things will just disappear. You can skip this step. Do not erase this minus, though. You didn't do anything to the minus. So now we've gotten rid of anything that's being added and subtracted. Our next grouping is anything that's multiplying or dividing our c. Do not mistake this cos for multiplication. As we've learned, this is sort of a unique operation. Its reverse is inverse cos. It is not multiplying and dividing. The only thing that multiplying it is a minus 2, an a, and a b. They're all multiplying. You can get rid of them all at the same time or one at a time. It doesn't matter. I'm going to do it all at the same time. The rules of algebra are I must divide both sides by the same thing. Like that. When I divide it on this side, it's clear that this disappears. So I'm left with this. This is pretty much it. You can even go to one extra step. You can say the reverse to get angle C. I want to get angle C all alone. So to get rid of this cos, I have to inverse cos both sides. So I'm going to put all this in brackets. And actually, technically, any numerator should be done as if it's in brackets, and any denominator should be done as if it's in brackets. And now if I'm going to inverse cosine, I should do another brackets. And this tells me to solve all this stuff in here before I do the inverse cosine. Which means if I inverse cosine this side, inverse cosine, which is that cos to the -1, or arc cosine it's also called, in case you come across that, I have to do that on the right side as well. Well, arc cosine is the opposite of cosine, so that cancels these two things. And we're left with angle C, which should have been in there the whole time, is equal to the inverse cosine after when you take c squared, subtract a squared, and subtract b squared, and then divide it by minus 2ab. Whatever number you get out of that, you then inverse cosine it. Now, obviously, you don't have to do that last step. I'm just showing you that algebraically you could do. This is good enough. Now, if we have three sides, we can plug in one side there, the other side there, the other side there, the side A there, side B there. We can solve all this, and then we can inverse cosine it to find angle C. But this here is the formula to use when we have three sides. It's the same formula. It's just been rearranged according to the rules of algebra. You could have rearranged it if you wanted to say it in the beginning. You could have said, Peter, you know what? I can't see that a squared and b squared are being added to it. But I can see that c minus 2ab times cos c is being subtracted from a squared, b squared. Why don't you just add that to both sides? You're right. I can. As long as I add the whole thing that's being subtracted, I can add this to both sides. Like that. And I just got to pause for a second. So I've added C2 plus 2AB to both sides. What happens on this right side? They cancel out. Notice it's going to be very similar. Now I'm going to subtract c squared. You might say, oh, it's slightly different. I don't have the same minus a squared and b squared. You're right. It's all really that's happening here is the minuses are all changing. And then I'm dividing it by 2ab on both sides. You might say, Peter, this is different. This is different than what you showed me 2 seconds ago. 2 seconds ago it was c squared minus a squared minus b squared, like this. Divided by negative 2ab. You're right. The only thing that's happened here is, and this has a plus in front of it instead of a negative. This is negative, this is plus, this is positive, this is negative, this is positive, this is negative, this is negative, this is positive. The negatives will all cancel out. These are actually the same equation, just a negative. For instance, if I divide everything up here by minus 1 and factor out a minus 1, I get minus c squared plus a squared plus b squared. If I factor a minus 1 out of here, now I have minus 1 taken out of this and minus 1 taken out of this. These cancel and become positive 1. I get the same equation. It's the same equation now. So really they're the same equation. One's been multiplied by minus 1 and one hasn't. I would just prefer you use whatever you're comfortable with. This second one was an example, so I would just use the first one. Whenever you have three sides, I would, if I were you, use the algebraic one that I provided you. Now on to the questions. This first one, number 1, is more of a theoretical question. They're giving us a side and the opposite angle, and then another angle. You should really be using the sine law. It's easier, and it's cleaner. It's faster. Let's look at if it is even possible to use the cosine law when we have that. And I find this question is a horrible one to introduce first. So they're saying our A is 5 centimeters. They're saying our angle of A is 52, and they're saying our B is 7 centimeters. So notice that the angle is opposite. The angle here is opposite that. So that technically, even though it's labeled as A is actually opposite the angle we're interested in. In the equation, that's the same as C, and that's angle C in the equation. We have 7, and we're missing this one. This is a horrible question to start you out on because it doesn't make a simple calculation. So now if we're looking at the equation for cosine, C squared is equal to A squared plus B squared minus 2 times A times B times cos of angle C. This introduction is horrible because they've labeled our C as A and our angle A, which is in the formula going to be angle C. It just makes it confusing. So if I look at what I have here, I have one of these sides. I have the opposite side, which is normal. These should have squares over them. I have the opposite side, which would normally go here, and this missing side is either A or B. So it's a really stupid and damaging question. It's why I don't like when they're trying to show you that you can use cos law even when you have the ability to use sine law. So if I look in terms of this equation, the cos equation, in terms of the information they've given me, and if I use these labels for these things here, C side is always opposite the angle I'm interested in. So they've given me angle C. They've given me the C side. And they've given me one of the sides. Doesn't matter if you call it A or B. Which means the thing I'm missing is B. This side over here. But I would instantly say use the sine law. We're missing C. C over, you can figure out, they even give you the 43 down here, angle C, 43. Which means C divided by sine of 43 is equal to 5 divided by the sine of 52. Why wouldn't I use the sine law? But if I'm forced to use it, yes, I can. Why would I? I don't know. Why are they giving me ABC and it doesn't match the equation? It's a foolish thing to do. So now if I fill this in, it's 5 squared is equal to a missing A squared is 7 squared plus a missing B squared minus 2 times A times a missing B again times cos of 52. That's insane because now I have to do a quadratic equation to solve this because I got a missing B squared here and a missing B there. This is a stupid first question. I would instead say to you, if you see the situation, you should only use cos law if they give you side, 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 or side, angle, side. Do not force yourself to answer questions like this. It sends you down a path of confusion. I am shocked that this is the first question, and I am not going to do it. Nor should you. All right, continuing on. To solve this, by the way, takes the quadratic equation, which we haven't really focused on or learned. And the reason it takes a quadratic equation is because you have a missing B squared and a missing B. The only way to solve that is to use the quadratic equation. Horrible, horrible first question. Okay, so we're going to go onwards. And we're going to look at number 2. Determine the side length x. So let's see if we can just kind of figure it out. So because you're looking for the equation, the answers, as opposed to how to do it, I'm going to quickly show you what we have. We have side, angle, side. So we use the basic one. We're trying to find x, which is our c. So our c squared or our x squared is going to be a squared plus b squared minus 2 times a times b times the cos of our angle c. We have our a. We have our b. We have our angle c. So that means you should fill it all in on this right side and solve it. And here's the answers you should get. And here's a little trick. If you want to verify your answers, you can pull up quite easily what's called a cos law calculator. And you can even tell it which one, what are we looking for? We're looking for side C. We have side A, 15. We have side B, 18. And we have angle C they want, 46. And side B, 18. And then we hit calculate. And they tell us that it's 13.1865. Okay? Now, I'm showing you the formula that you should solve and fill out. You solve and fill it out. But if ever you want to verify your answer, look up cosine, law of cosine calculator, calculator soup. Depending, click on what you're looking for, and then it will let you fill in the relevant and then click calculate. It's much easier if you're going to, don't use it to get the answer, use it to verify the answer. Now all our sides are rounded to 1 digit, so the answer is probably 13. Okay, looking at the next one, this is side, 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 isn't it? So you should use the other formula. The other formula is equal to is this. Cosine is equal to c squared, and this should all have squares on it, is equal to c squared minus a squared minus b squared, all divided by -2 times a times b. And these should all have squares on them. Keep in mind, the minus is opposite the square. In other words, you square the number and then subtract it. It's more of a formula. And it's going to be divided by this. So we're going to use this. But guess what? I'm going to pull up my calculator. What are we looking for? We're looking for angle C. Okay, and now, so tell us the sides. 5.9, 2.3, 6. It actually doesn't matter which ones you put in for A, B, and C because it's all three sides. And then you say calculate. And it tells me this angle is 86.49, assuming I punched in the numbers right. 5.9, 2.3, 6.2. Tells me that angle C, which is the opposite of side C, so that means the opposite C. I've made my side C 6.2, so that means the angle opposite that one is 86.5 because they have 2 digits. That's another thing you have to be very aware of. How does this angle C relate to this? It relates to side C. So whatever I put in for side C, the opposite angle is the angle I'm looking for. Now that I have an angle and a side, I can use the sine law to figure out the other angles. And all I have to figure out is one more angle, and then I can use 180 minus those 2 angles if I was asked to find all the angles. You always want to use the simplest process to answer these questions. Let's continue on. Determine each unknown side. Guess what I'm going to use? I'm going to tell you the formula you should be using, and then you're going to use you're going to do it yourself and use the calculator. We have side, angle, side. That means I use the normal one. I have side, angle, side. So in both cases, I should label my A and my B. I should note that it's to 1 decimal place, and I should label my angle C, which means the side that I get will be the opposite side to this angle, be over here. So that means I use the basic formula. I'm finding C squared. I need to have A squared plus B squared minus 2AB times the cos of 40. And I just have to make sure I don't mess up the calculations. And if you want to get technical, you can even get rid of this square right now. You'll see this sometimes. C is actually equal to the square root of all that, because we square root it at the end, don't we? But just keep it like that. That's fine. Now, instead of doing that, what am I going to do? I'm going to tell it I have side, angle, side, so I'm looking for side C. And I have side A as 10.5. I have angle C as 40. And I have side B as 9.5. Calculate. And there we go. It tells me that the other side is 6.9 because we're into 1 digit. So that means this side over here is 6.9. Now that I have this side, I can use the sine law to figure out this other angle or this other angle. So the sine of 40 divided by 6.9 is going to be equal to the sine of this angle C divided by 10.5, or the sine of angle A divided by 9.5. Use the simpler formula. Once I find the second angle, I'm just going to use 180 minus those 2 angles for the third one, because that's the simpler formula. What do I have here? Same thing. Just the ABCs have changed, 13 and 11 and 75. This is a big angle, so I can expect this side to be quite long, or longer than the other sides. So I'm going to pull up my calculator, but I'm still looking for angle C, so it's 13, 75, and 11. And I'm going to hit calculate. And it's going to tell me the other side is 14.69. And because we're rounded up to single digit, 14.69 becomes 15. Which means this other side is indeed the longest side, 15 longer than 13, longer than 11, because that angle there is probably bigger than these other two. Note that 15 is close to 13, so this angle will be slightly less than 75. And this 11 is the smallest, so this angle will be the smallest. The opposite angle, whatever's the smallest side, will have the opposite angle will be the smallest angle. Just a sort of rule of thumb if you ever have to verify if you got something right or wrong. So let's continue. This one gives me side, side, side. So I label them A, B, C, and I use the formula. What do I use? Now I'm looking for angle C, right? So angle C, the cos of angle C, is going to be equal to C squared minus A squared minus B squared, all divided by negative 2AB. 2 times A times B. And you should do all this as one operation. Subtract C squared minus A squared, and then divide it by that whole thing. Don't do this divided by 2 divided by A divided by B. Figure out what that is, figure out what that is, take that, divide it by that, if you're not comfortable with a calculator. If you are comfortable with a calculator, use your parentheses. Open parentheses, do all this, close parentheses, hit division, open parentheses, take minus 2 times A times B, close parentheses, hit equals, and it should do it for you. But, like I said, I'm going to use my calculator. I'm looking for angle C. So I have the sides of the first one. I have 3.5, 3.9, and 2.2, I think it says. Hit calculate. Which C am I looking for? I have to make sure I made my side C 2.2 because that's over here, and I did. So that means that angle is 34.0 because we're rounding to one decimal place. So 30, and there's a 4 after, so it's just 34.0. Might say, why not say 34? The 0 tells the teacher that we have indeed looked at the decimals afterwards because we're working clearly with the first decimal. We're working with the first decimal here too. 3 sides. What's the angle we're looking for? This one over here. So that makes this our side C. That's the only thing you have to be careful of. So this time my side C is 2.9. My other sides are 2.6. It doesn't, for A and B, it doesn't matter which one you assign. And then I hit calculate. And this time my angle is 73.806. I want 73.8086. And I want to first decimal. The number after the 8 is 0. So it's 73.8. So that means this angle here is 73.8. Makes a lot of sense because that's the longest side and that's a big angle. So I should expect the other angles. This will be the smallest angle because that's the smallest side, and this will be the medium angle over there. This angle here will be close, but smaller than 73.8 because 2.6 is close to 2.9. But we want one decimal. They could even ask you all the angles. At this point, we would move to the sine law. Next one. Next one you solved fine. What's the information we're missing on this first one? Oh, SRT. Okay, so they give us SRT. We're going to always draw it when they give it to us. Okay, they tell me I must as well label it SRT. They tell me angle S is 60. They tell me little r, which is opposite big R, is 15. They tell me little t, which is opposite angle T, that. So clearly the side C will be opposite the angle. This is C. We need C, so we're going to use the same, the general one. A squared plus B squared minus 2AB cos 60. And you just fill in the AB. The A is 15, the B is 20. But I'm not going to do that. I'm going to use my calculator. I don't want you to use the calculator. I want you to do it by hand and then use the calculator to see if you got it and where your mistake was. So that means we're going to look for side C. We're going to make side A 15. We're going to make angle C 60. And we're going to make side B 20. I'm going to hit calculate. And we discover, since we're working just with one unit, 18.027 is just 18. Now that I have side C, if they wanted other information, I could continue with the sine law to find the other angles. Let's continue. That was 6. Now we're going to go to 7. We need this cone for 7. And you kind of did the cone. Notice that it's a little confusing because they say the diameter of the circle up top. But if you look carefully, get rid of the image, that's really the triangle, blue triangle they're looking for. This side is opposite the angle, so that's side C, which means we don't use our normal formula, C squared is equal to a squared plus b squared minus 2 times a times b times cos of 36. Work it all out, put in your calculator. The a is 17. Wherever you see a, you put 17. The b is 17 as well. So wherever you see a is that, you put 17. And there you go. It's a calculated game now. I can't, come on. My OCD is kicking in. So there we go. I've got that. So now I can go over here and say, yeah, I'm still looking for side C, only this time the sides are 17, the angle is 36, and the sides are 17. And I can hit calculate. And an interesting thing, when two sides are the same, these top two corner angles will be the same. So, I mean, technically I could have cheated here. Knowing these sides are the same, I instantly know these angles here and here are the same. Since there's 180 degrees and 36 is used up, I have 144 left. This has to be divided equally on these two corners, which means each corner is 72. I could have cheated and used the sine law. And we should, you know what? Let's see if the sine law gives us the same answer. So according to me, each corner is 72. So I'm going to do that. Say 72 degrees and 72 degrees. Let's use the cos law to see what c squared we get, and then let's use the sine law to see what c squared we get. And I'm just going to pause this for a second. There we go. Okay, so now let's verify our answer. And our side is A. Oh, we already verified the answer, didn't we? We discovered that C was what? Let's just make sure. So calculate. We discovered that C is 10.5. Okay, and it actually rounds up to 11 because they're using one digit. So apparently C is 11. Now let's see if we could have cheated and used the sine law. According to me, if I'm looking for C, C divided by the sine of 36 will be equal to 17. And I discovered that the corner is sine of 72, which means if I multiply both sides by sine of 36, 17 times sine of 36 divided by the sine of 670, divided by the sine of 72 should get me the same answer. Let's see if that does. I'll use a calculator instead of sine. Well, so 17 times 36 sine equals divided by 72 equals. Sure enough, I get the same answer with using the sine. I could have been tricky and cheated. All right, and the last question, which you've already done. Notice, I want you to notice something here. These sides are incredibly long, 100 centimeters. This is a pendulum that's supposed to be swinging back and forth and back and forth. This side's incredibly long compared to how wide it's swinging, which means when these sides are huge and this side's tiny, that angle is going to be tiny. Well, really, if we're going to draw it to scale, because this is not drawn to scale, it's going to look more like this. Yes, that's not even accurate because I made the left one too far. It's going to look more like that. And that is more exact. That's a better drawing of something that's 100 long compared to 2.6. So you can see how tiny that angle is. Why don't they draw it to scale? Well, one, they'd have to draw down the whole book. Two, if they don't draw down the whole book, you can't see the angle up here. So this is not an accurate version of what they're talking about. This is. These strings very long compared to the swing. So it's the same calculation, though they've given me two sides. Three sides, haven't they? So that means we're going to use this formula. The cos of angle C is equal to C squared minus A squared minus B squared, all divided by negative 2AB. Fill in your things, because C is 90.6. Always make sure you get your C right. So C here is 9.6. A is 100. B is 100. A is 100. B is 100. I can do it two ways. I can throw up the calculator and do it. I'm not supposed to teach you how to do it on a calculator properly. So I'm going to do it on calculator with parentheses. I can treat my numerator as parentheses. I can open it up. I can say, what's c squared? Well, my c is 9.6. I can say, find that squared for me. And then I can say, subtract a squared. And a squared is 100 times 100. 1 with 4 zeros, because 100 times 100 is 2 zeros. Then I could say, subtract another 10,000. You might say, oh my God, I've got a negative number, but that's okay, because now we're going to close the parentheses, and we're going to divide it by open parentheses, negative 2, there's my plus minus, there it is, times a times b, close parentheses. Now I've done the bottom. Now I hit equals. And you can see the two negatives cancel out. I get that. Well, that tells me that cos of this angle is equal to that, which means I have to take the arc cos, or the inverse cos, of both sides. It cancels. Cos cancels on this side. Inverse cos and cos. So I'm left with this, inverse cos of that number. So that means I just take that, and you can see algebra still works. So I just go to trigonometry, second function, inverse cos, and I get a distance of 5.5. And because we're working in 1 decimal, 5.5 degrees, because we're talking about an angle. Again, notice that both these sides of the pendulum are the same, which means both these angles down here will be the same, which means 180 minus 5.5 gives me 174.5. If I divide that by 2, which is 87.25, that's both the angles in the corner. There and there. Just because I know my equilateral triangle, no, not equilateral, isosceles triangle. And be aware that 1/10 of a degree means 0.1 decimal. It's not the same thing. 1/10 of a second, for instance, is 0.1 seconds. There you go. That's every question.